Assalamualaikum warahmatullahi wabarakatuh. We are from group 1 with member me, Gayu Aditya Hutomo, study number 521341905 and my partner Julia Ersanetadia with study number 521341920. In this opportunity, we will describe about our material is natural gas and crude oil. The first material is natural gas. Natural gas separated into two, that is non-associated natural gas and associated natural gases. Natural gas, the definition. Natural gas is a naturally occurring mixture of light hydrocarbon accompanied by some non-hydrocarbon compounds. So the light hydrocarbon is methane and the non-hydrocarbon compounds is another compounds like nitrogen and CO2. First is non-associated natural gases. Non-associated natural gas is found in reservoir containing no oil or dry wells. In the non-associated natural gas, there is no oil contained in natural gas. The second is associated natural gases. Associated natural gases is present in contact with and or dissolved in crude oil and it co-produced with it. So in associated natural gas is contain a crude oil. Next is natural gas treatment processes. Actually, natural gas treatment process is separated into three processes, that is acid gas treatment, water removal, and condensable hydrocarbon recovery. But in acid gas treatment, that is separated into three again, is physical absorption, and chemical absorption. First is acid gas treatment. Acid gases can be reduced or removed by one or more of following methods. One is physical absorption using a selective absorption solvent. Two, physical absorption using a solid adsorbent. And three, chemical absorption where a solvent, a chemical, capable of reacting reversibly with the acid gases is used. First method is physical absorption. Important processes commercial use are the Selexol, the sulfinol, and rectisol processes. The solvent or absorbent is a liquid that selectively absorbs the acid gases and leaves out the hydrocarbons. Raw natural gas pays counterly to the scanning solvent. When the solvent becomes saturated with acid gases, the pressure is reduced, and hydrogen sulfide and carbon dioxide are dissolved. The solvent is then recycled to the absorption tower. So in the physical absorption, we use solvent like Selexol, the sulfinol, and the rectisol to absorb the acid gases. The next method is physical adsorption. In these processes, a solid with a high surface area is used. Molecular sieves like zeolites are widely used and are capable of absorbing large amount of gases. In practice, more than one adsorption bed is used for continuous operation. One bed is in use while the other is being regenerated. Regeneration is accomplished by passing hot dry fuel gas through the bed. Molecular sieves are competitive only when the quantities of hydrogen sulfide and carbon disulfide are low. Molecular sieves are also capable of absorbing water in addition to the acid gases. So in the physical adsorption, the solvent like zeolite is adsorbs a natural gas. The last method is chemical absorption or chemisorption. These processes are characterized by a high capability of absorbing a large amount of acid gases. They use a solution of relatively weak base such as monoethanolamine. The acid gas forms a weak bond with the base which can be regenerated easily. Mono and diethanolamines are frequently used for this purpose. The amine concentration normally range between 15 and 30%. Natural gas is passed through the amine solution where sulfides carbonates and bicarbonates are formed. So in this method, we use a weak base that is can be bond with which can be bond with acid gases. Okay, the next process is water removal. Moisture must be removed from natural gas to reduce corrosion problems and to prevent hydrate formation. To prevent hydrate formation, natural gas may be treated with glycols, which dissolve water efficiently. Ethylene glycol or EG, diethylene glycol or DEG, and triethylene glycol or TEG are typical solvents for water removal. The next material is condensable hydrocarbon recovery. Hydrocarbons heavier than methane that are present in natural gases are valuable raw material and important fuel. So in the natural gas there is no pure methane, but there is another compounds like C2 until C6. They can be recovered by lean oil extraction. Another way to recover NGL is through cryogenic cooling to very low temperature, about minus 150 until 180 degree Fahrenheit, which are achieved primarily through adiabatic expansion of the inlet gas. Okay, the next material is natural gas liquids or NGL. Natural gas liquids or condensable hydrocarbon are those hydrocarbons heavier than methane that are recovered from natural gas like C2 and C2, C3, C4. The amount of NGL depends mainly on the percentage of the heavier hydrocarbon present in the gas and on the efficiency of the process used to recover them. Natural gas liquid may contain significant amount of cyclohexane, a precursor for nylon 6. In natural gas liquids or NGL, there is separated into three. Is an ethane-rich steam, which is used for producing ethylene, liquefied petroleum gas or LPG, which is a propane-butane mixture, and natural gasoline or NG is mainly constituted of C5 plus hydrocarbon and is added to gasoline to raise its vapor pressure. First is liquefied natural gas or LNG. After the recovery of natural gas liquid, sweet dry natural gas may be liquefied for transformation through cryogenic tankers. Two methods are generally used to liquefy natural gas: the expander cycle and mechanical refrigeration. In the expander cycle, part of the gas is expanded from a high transmission pressure to a low pressure. This lowers the pressure of the gas. In mechanical refrigeration, a multi-component refrigerant consists of nitrogen, methane, ethane, and propane is used through a cascade cycle. Next is properties of natural gas. Treated natural gas consists mainly of methane. The properties of both gases, natural gas and methane, are nearly similar. However, natural gas is not pure methane, and its properties are modified by the presence of impurities such as nitrogen and CO2, and small amount of unrecovered heavier hydrocarbon. Okay, the next material is raw material and petrochemical products. This material will be described by my partner, Julia.
The next material is crude oil. One of the petrochemical raw materials beside natural gas is crude oil. Before I explain these three crude oil materials, I will explain the definition of crude oil. Crude oil or petroleum is a naturally occurring brown to black flammable liquid. Crude oils are principally found in oil reservoirs associated with sedimentary rocks beneath the Earth's surface. I will explain three topics about crude oil. The first, composition of crude oil. Second, properties of crude oil. And the last, crude oil classification. As you can see, The composition of crude oil is hydrocarbon compounds, non-hydrocarbon compounds, organometallic compounds, and inorganic salt. The first composition of crude oil is hydrocarbon compounds. Hydrocarbon compounds is generally classified into alkanes, paraffins, cycloparaffins or naphthanes, and aromatic compounds. Alkanes or paraffins are saturated hydrocarbon having the general formula CnH2n plus 2. The simple alkane, methane, is the principal constituent of a natural gas. And the next, cycloparaffins or naphthanes. Saturated cyclic hydrocarbon, normally known as naphthanes, are also part of the hydrocarbon constituent of crude oil. The ratio, however, depends on the crude type. Cyclohexane, substitute cyclopentanes, and substitute cyclohexane are important precursors for aromatic hydrocarbon. And the last, aromatic compounds. Lower members of aromatic compounds are present in a small amount in crude oil and like petroleum fraction. Benzene, toluene, and xylene or BTX are important petrochemical intermediates as well as a valuable gasoline component. And the second composition of crude oil is non-hydrocarbon compounds. Non-hydrocarbon compounds consist to three types, namely sulfur compounds, nitrogen compounds, and oxygen compounds. Sulfur compounds. The sulfur in crude oil is mainly present in the form of organosulfur compounds. Hydrogen sulfide is the only important inorganic sulfur compound found in crude oil. Sulfur compounds in crudes may generally be classified into acidic and non-acidic sulfur compounds. And the next, nitrogen compounds. The nitrogen content in most crudes is very low and does not exceed 0.1%. Nitrogen compounds in crudes may generally be classified into basic and non-basic categories. And the last, oxygen compound. Oxygen compounds in crude oil are more complex than the sulfur types. However, their presence in petroleum streams is not poisonous to processing catalysts. Many of the oxygen compounds found in crude oil are weakly acidic. Oxygen compounds in crudes may generally be classified into acidic and non-acidic categories. And the last composition of crude oil is metallic compounds. Many metals occur in crude oils. Some of the more abundant are sodium, calcium, magnesium, aluminum, iron, vanadium, and nickel. They are present either as inorganic salts, such as sodium and magnesium chlorides, or in the form of organometallic compounds, such as those of nickel and vanadium. Although metals in crudes are found in a trace amount, their presence is harmful and should be removed. When crude oil is processed, sodium and magnesium chlorides produce hydrochloric acid, which is very corrosive. Desalting crude oil is a necessary step to reduce the salt. And the second topic is properties of crude oil. Properties of crude oil consist of 5 types, namely density, specific gravity, and API gravity, salt content, sulfur content, pour point, and S content. And the first, density is defined as the mass of a unit volume of a material at a specific temperature. Specific gravity is used to calculate the mass of a crude oil and its product. The API, or American Petroleum Institute, gravity is another way to express the relative masses of crude oil. The API gravity could be calculated mathematically using the following equation. A low API gravity indicates a heavier crude oil or a petroleum product, while a higher API gravity means a lighter crude or product. And the second is salt content. A high salt content in the crude oil presents serious corrosion problem during the refining process. In addition, high salt content is a major cause of plaguing heat exchanger and heater pipes. And the third is sulfur content. Determining the sulfur content in crudes is important because the amount of a sulfur indicates the type of the treatment required for distillates. The sulfur content of crudes, however, is important and is usually considered when determining commercial values. And fourth is pour point. The pour point of crude oil or product is the lowest temperature at which an oil is observed to flow under the condition of a test. Pour point data indicates the amount of long-chain paraffins or petroleum wax found in the crude oil. And the last, S content. This test indicates the amount of metallic constituent in the crude oil. The ash left after completely burning an oil sample usually consists of stable metallic salts, metal oxide, and silicon oxide. The ash could be further analyzed for individual elements using spectroscopic technique. And the last topic is crude oil classification. Appreciable property differences appear between crude oil as a result of the variable ratio of the crude oil component. For a refiner dealing with crudes of different origins, a simple question may be established to group crudes with similar characteristics. Crude oil can be arbitrarily classified into 3 or 4 groups depending on the relative ratio of the hydrocarbon classes that predominates in the mixture. And the first, paraffinic. The ratio of paraffinic hydrocarbon is high compared to aromatics and naphthanes. And the second is naphthenic. The ratio of naphthenic and aromatic hydrocarbon are relatively higher than in the paraffinic crudes. And the last, asphaltic. Contain relatively a large amount of polynuclear aromatics, a high asphaltene content, and relatively less paraffin than paraffinic crudes. And the next method is petrochemical product. To find petrochemical products, we can separate them into two parts, namely upstream petrochemical and downstream petrochemical. Upstream petrochemical is the part of the process of making basic products or premier and will produce semi-finished products or intermediate products. Can be directly processed with finished product in the downstream industry. And a downstream petrochemical is the section moved as an intermediate product processor to a finished product so that it can be used by the community. And for upstream petrochemical, the example of basic product is synthetic carbon and H2 gases, ethylene, propylene, butadiene, benzene, toluene, silane or BTX, and N-paraffin. And the example of intermediate product is ammonia, methanol, carbon black, urea, ethanol, ethyl chloride, and so on. As mentioned previously, the BTX or benzene, toluene, and silane is the composition of crude oil. Yes, it's aromatic compounds. In the petroleum refining and petrochemical industry, the initialism BTX refers to a mixture of benzene, toluene, and the 3-silane isomer, all of which are aromatic hydrocarbon. The BTX aromatics are very important to petrochemical materials. Toluene is also a valuable petrochemical for use as a solvent and intermediate in the chemical manufacturing processes and as a high-octane gasoline component. BTX can be made by various processes. However, most of BTX production is based on the recovery of aromatic derivatives from the catalytic reforming of naphtha in a petroleum refinery. Catalytic reforming usually utilizes a feedstock naphtha that contains non-aromatic hydrocarbon with 6 to 12 carbon atoms and typically produce a reformate product containing to 6 to C8 aromatic or BTX, as well as parabens and heavier aromatics containing 9 to 12 carbon atoms. You can see the schematic flow diagram for the extraction of BTX aromatics from a catalytic reformate. Another process for producing BTX aromatics involves the steam cracking of hydrocarbon, which typically produce a cracked naphtha product, commonly referred to as pyrolysis gasoline, pyrolysis gas or P-gas. The pyrolysis gasoline typically consists of C6 to C8 aromatics, heavier aromatics containing 9 to 12 carbon atoms, and non-aromatic cyclic hydrocarbons or naphthanes containing 6 or more carbon atoms. There are very large number of petrochemical produced from the BTX aromatics. You can see the diagram, the chain of the petrochemical derivative from the BTX aromatics. So, from BTX can produce nylon, polyester fiber, and resins, and so on. And for downstream petrochemicals, the example of finished product or intermediate products is a urea, carbon black, formaldehyde, acetylene, and so on. And the final product is the item that are widely used every day at home stairs, as a plastic for electronic and telecommunication products, as a radio, TV, computer equipment, the plastic for household, plastic for the car and the aircraft industry, as a bumper, seats, and tires of a car or airplane, shirt and socks made of polyester and nylon thread, and the last, detergent soap powder made from lead sulfonate. And the next material is coal, oil shale, tar sand, and gas hydrates. The first is coal. Coal is a natural combustible rock composed of an organic heterogeneous substance contaminated with variable amounts of inorganic compounds. Coal is classified into different ranks according to the degree of chemical change that occurred during the decomposition of plant remains in the prehistoric period. In general, coals with a high heating value and a high fixed carbon content are considered to have been subject to more severe change than those with a lower heating value and fixed carbon content. For example, peat, which is considered a young coal, has a low fixed carbon content and a low heating value. Important coal ranks are anthracite, or which has been subject to the most chemical change and is mostly carbon, bituminous coal, and sub-bituminous coal and lignite. And the next is oil shale. Oil shale is a low permeable rock made of inorganic material interspersed with a high molecular weight organic substance called kerogen. Heating the shale rock produces an oily substance with a complex structure. The composition of oil shales differs greatly from one shale to another. For example, the amount of oil obtained from 1 ton of eastern U.S. shale deposit is only 10 gallons, compared to 30 gallons from a western U.S. shale deposit. Resourcing is a process used to convert the shale to a high molecular weight oily material. In this process, crushed shale is heated to high temperature to pyrolyze kerogen. The product oil is a viscous, high molecular weight material. Further processing is required to change the oil into a liquid fuel.
Okay, the next is tar sand. Tar sand or oil sands are large deposits of sand saturated with bitumen and water. Tar sand deposits are commonly found at or near the Earth's surface and trapped in large sediment basins. The sand is difficult to handle. During summer, it is soft and sticky, and during the winter, it changes to a hard, solid material. Recovering the bitumen is not easy, and the deposits are either strip mined if they are near the surface, or recovered in situ if they are in deeper bed. The bitumen could be extracted by using hot water and steam and adding some alkali to disperse it. The produced bitumen is a centimeter cubic, very thick material having a density of approximately 1.05 g per ounce. Is then subjected to a cracking process to produce distillate, fuel, and coke. The distillates are hydrotreated to saturate olefinic components. And the last material is gas hydrates. Gas hydrates are an ice-like material which is constituted of methane molecules exchanged in a cluster of water molecules and held together by hydrogen bond. This material occurs in large underground deposits found beneath the ocean floor or continental margin and in places north of the Arctic Circle, such as Siberia. It is estimated that gas hydrates deposits contain twice as much carbon as all the other fossil fuel on Earth. This source is proven feasible for recovery, could be a future energy as well as chemical source for petrochemicals. Due to this, due to its physical nature, a solid material only under high pressure and low temperature. It cannot be processed by conventional methods used for natural gas and crude oils. One approach is by dissociating this cluster into methane and water by injecting a warmer fluid such as seawater. Another approach is by drilling into the deposit. The reduce the This reduces the pressure and frees methane from water. However, the environmental effect of such drilling must still be evaluated. Okay, maybe that's all from our group. I apologize if there any problem in our presentation. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.